Hello and welcome to my YouTube channel ChemWis. In this video, we are going to discuss Bromo pattern in mass spectrometry. When a molecule has one or more bromine atoms in it, mass spectrum of the molecule displays a specific pattern of M, M plus 2, M plus 4, M plus 6, etc., based on which we can easily identify the number of bromine atoms in the molecule. There are two methods, detailed method and shortcut method. We will discuss both the methods, but first let's go through detailed method. Let's have a case 1 in which the molecule has one bromine atom. Bromine has two isotopes, Br79 and Br81. If we talk about their natural abundance, Br79 and Br81 are 50-50%. Or we can say that the relative abundance of Br79 and Br81 is 1:1. Suppose we have a molecule RBr with one bromine atom in it. If the mass of R group is W, then there will be two types of molecules, RBr79 with molar mass W plus 79 and RBr81 with molar mass W plus 81. The peak in the mass spectrum corresponding to W plus 79 is labeled as M, while that of W plus 81 as M plus 2 because the latter peak has 2 units higher mass. Their natural abundance will be 50-50 as the natural abundance of bromine isotopes. In other words, their relative abundance will be 1:1. Therefore, the intensity ratio of M and M plus 2 peaks will be 1:1. Thus, if mass spectrum of a molecule shows M and M plus 2 peaks with the intensity ratio of 1:1, then the molecule has one bromine atom in it. For example, bromobenzene. Since there are two isotopes of bromine, so in a sample of bromobenzene there will be two types of molecules, one with Br79 and other with Br81. We know that the molar mass of phenyl residue is 77. So the molar mass of bromobenzene with Br79 will be 77 plus 79 is equal to 156, and that of bromobenzene with Br81 will be 77 plus 81 is equal to 158. In mass spectrum, there will be two molecular ion peaks, one with M by Z 156 and other with M by Z 158. So the peak with M by Z 156 will be M, and that with M by Z 158 will be M plus 2 peak. The intensity ratio of M to M plus 2 peak will be equal to the relative abundance of bromine isotopes, that is 1:1. This is the mass spectrum of bromobenzene. These are two peaks, M and M plus 2, with M by Z 156 and 158 with the intensity ratio of 1:1. Case 2 in which a molecule has two bromine atoms. Let's represent the molecule as RBr2. A molecule may have both Br79. It may have one Br79 and one Br81. There are two possible combinations, molecules with Br79 and Br81 and molecules with Br81 and Br79. Third type of molecules are the molecules with both the Br81 atoms. The peaks in mass spectrum corresponding to these molecules respectively are M, M plus 2 and M plus 4. Since the relative abundance of Br79 is 1 and that of Br81 is also 1. So, the relative abundance of M will be 1 into 1 is equal to 1. Relative abundance of M plus 2 peak will be 1 into 1 plus 1 into 1 is equal to 2. And that of M plus 4 will be 1 into 1 is equal to 1. So, the intensity ratio of M, M plus 2 and M plus 4 peaks will be 1 is to 2 is to 1. Thus, if mass spectrum of a molecule has M, M plus 2 and M plus 4 peaks with the intensity ratio of 1 is to 1, then it has 2 bromine atom in it. For example, 1,4-dibromobenzene. There will be 3 molecular ion peaks M, M plus 2 and M plus 4. Since the mass of phenylene residue shown in blue is 76, so mass of M peak will be 76 plus 79 plus 79 is equal to 234. Mass of M plus 2 peak will be 76, 81 plus 79 is equal to 236. And mass of M plus 4 peak will be 76 plus 81 plus 81 is equal to 238. The intensity ratio of M is to M plus 2 and M plus 4 peak will be 1 is to 2 is to 1. This is the mass spectrum of 1,4-dibromobenzene. These are M, M plus 2 and M plus 4 peaks with M by Z 234, 236 and 238 with the intensity ratio of 1 is to 2 is to 1. Let's study case 3 in which a molecule has 3 bromine atoms. We can represent the molecule like as: based on isotopic distribution of bromine atoms, there are 4 possible sets of molecules. Molecules with 3 Br79 isotopes, molecules with 1 Br81 and 2 Br79. In this set, there are 3 possible combinations of bromine isotopes: 81 79 79, 79 81 79, 79 79 81. Third set of molecules will be with 2 Br81 and 1 Br79. So, in this set too, there will be 3 possible combinations: 81 81 79, 79 81 81 and 81 79 81. And the fourth set of molecules are the molecules with 3 Br81. These sets will correspond to M, M plus 2, M plus 4 and M plus 6 masses. Since relative abundance of Br79 is 1 and that of Br81 is also 1, so the probability of finding these combinations will be 1 into 1 into 1 is equal to 1, 1 into 1 into 1 is equal to 1, 1 into 1 into 1 is equal to 1, 1 into 1 into 1 is equal to 1, 1 into 1 into 1 is equal to 1, 1 into 1 into 1 is equal to 1, 1 into 1 into 1 is equal to 1 and 1 into 1 into 1 is equal to 1. Therefore, the relative abundance of M is equal to 1. M plus 2 is equal to 1 plus 1 plus 1 is equal to 3. M plus 4 is equal to 1 plus 1 plus 1 is equal to 3, and that of M plus 6 is equal to 1. Thus, the intensity ratio of M plus 2, M plus 4 and M plus 6 peaks in the spectrum of a molecule containing 3 bromine atoms will be 1:3:3:1. Now we will discuss shortcut method to find the Bromo pattern in mass spectrometry. We can find the Bromo pattern by the formula A plus B power n, where A is the relative abundance of lighter isotope and B is the relative abundance of heavier isotope. Let's discuss case 1 in which there is only one bromine atom in a molecule. So in this case, n is equal to 1, and we know that in the case of bromine, the relative abundance of lighter isotope, that is Br79, is 1, and that of heavier isotope, that is Br81, is also 1. So here A is equal to 1 and B is also equal to 1. Now putting these values in the formula of A plus B power n will give A 1 plus 1 power 1 or 1 plus 1. This is the relative abundance of M and this is the relative abundance of M plus 2. So the relative abundance of M and M plus 2 peaks will be 1:1. Case 2 in which there are 2 bromine atoms in a molecule. In this case, n is equal to 2, A is equal to 1 and B is equal to 1. Since n is equal to 2, so the formula will become A plus B power 2. Upon expansion, it will become A square plus 2AB plus B square. Putting the values of A and B will give 1 square plus 2 into 1 into 1 plus 1 square, or 1 plus 1 plus 2 plus 1. These are the relative abundance of M, M plus 2 and M plus 4 peaks. Thus, the intensity ratio of M plus 2 and M plus 4 peaks will be 1:2:1. Case 3 in which a molecule has 3 bromine atoms. Here n is equal to 3, A is equal to 1 and B is equal to 1. Putting the value of n in the formula A plus B power n will give A plus B power 3. Upon expansion, it will become A power 3 plus 3A square B plus 3AB square plus B power 3. Putting the values of A and B will give 1 power 3 plus 3 into 1 square into 1 plus 3 into 1 into 1 square plus 1 power 3, which will be equal to 1 plus 3 plus 3 plus 1. These are the relative abundance of M, M plus 2, M plus 4 and M plus 6 peaks. Thus, the intensity ratio of M, M plus 2, M plus 4 and M plus 6 peaks will be 1:3:1. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.